I want to challenge the Flat Earth community to the most basic thing. Actually, this is something that they would need to explain before they could go on to flip out about Coriolis or flip out about any of the other dumb things that they speak about. I want to put out a challenge to their claims, Dell, Nathan Oakley, and Arwijn. And I want them to explain how the day-night cycle would work on the Flat Earth. Professor Dave Explains handles this in one of his videos. Remind myself to cut there.
This is the one you showed me to explain the seasons. It attempts to account for the temperature differential throughout the year, but I'm sorry, it's not compatible with observation. Here's why. These are the two tropics. I don't know what you think these circumferences are, but it's safe to say that this one is smaller than this one. If that's the case, one of two things must be true. Option 1, this object maneuvers the inner path in a shorter amount of time than it maneuvers the outer path, which would make summer shorter than winter. It's not. Option 2, it moves much slower up here and much faster down here so that all of the circles take the same amount of time. That would mean the sun moves through the sky at different speeds throughout the year. It doesn't. So sorry, this model doesn't work.
Maybe if I clap, it'll put a little spike in my audio. Okay, we'll put that clip in. Professor Dave Explains perfectly demonstrates the problem with the flat Earth model on the most basic level. So how can you go on to these complicated things is the question. So let's go into the universe. Well, not the real universe. This is the universe represented in a very complicated algorithm. And let's actually take a look at what our model looks like. See, this is the problem, and I want to demonstrate this to flat earthers right now. This is our day-night cycle. This is a globe of the Earth. And what it does is it's facing the sun, as we can see, if I can find it, that way out there. Now, it looks big, doesn't it? Don't worry, it won't in a second. But the sun is shining, and we are rotating around it. And here is our Earth. And you can see how there is a terminator line. You see it? It's where sun sets and rises. You get the point. Actually, we can kind of just go and roll right around. And this program is so accurate. I know flat earthers won't believe me. Is that the moon? Hey, there's the moon. We'll actually take a trip to the moon in just a little bit. Wonder if I could fly out there right now. No, I won't be able to. But I don't want to lock myself off the Earth. Here's how our model works. Here's the day-night cycle literally right in front of you. And I'll do us a favor even. I'll get us positioned real nice so we can watch this little terminator line here. And I'll try to bring the sun into frame the slightest bit. There we go. And I'm going to speed up time, if I remember how. And we will watch in 1 to the 10th power of 6 time as we rotate as I talk. Okay, so here's our day-night cycle. And as you can see, not only can we show this with computer models, but we can actually show it with mathematics because that's how the computer models work. That's a problem that we'll talk about in a minute that Sleeping Warrior had when he talked to AB Science. I'll go into that later. But the mathematics not only can be observed, so you can go out and every one of the objects that you see, you just saw the moon rotate right in front of in between the moon, the sun, and the Earth. We can predict this. We can say exactly where it's going to be. We can observe it from the Earth at any time, and we can see that the math puts all of these objects right where they need to be in our model at any time. That is how we know that our model is legit. Now, sure, there's problems with the model. There are complicated things with the model, and there are things that are hard to understand about the model. And that's why you have to go to college and take a lot of class in order to even learn some of the more middle line points about our model. But in the end, the model works better than any model ever could. So my next point, I'll use Saturn to be able to make my next point for the flat earthers. The beauty of the universe and the solar system is lost on a flat earther because they don't believe that these planets are what you're looking at right now, which they are provably. So let's speed up time. So this is what is happening around Saturn as time goes forward, but this is extremely sped up. And as you can see, it's one thing that scientists can do is tell you where any of these objects are at any given point in the next million years, and it literally be able to happen. You can actually test it by, of course, not going out millions of years, but just going out in our lifetime and say, predict where everything will be at in a week. And then they can do it, and you can go look up in the sky and see that they are correct. So let me show you something. To exercise my point, we're going to zoom out. And this is insane, but awesome. This is Saturn. It's starting to show you additional bodies that fly around Saturn. But we're going to move out and start looking at you're going to see some of the other bodies here and stars. And you can see that this is the sun. Yeah, and this is our solar system. But let's go even further. Let's zoom out. And as you can see, there's our solar system, but it even can map bodies that are near our solar system until we can get near star systems as we zoom out more and more. So these are star systems near our star system. So something that's lost on flat earthers, I'll say point 3, is the scope of how big it all is. And that's one thing you definitely know that flat earthers cannot grasp. But look, this is just near our solar system. These are just stars with their own solar system near ours. And let's zoom out. Starts to look really pretty, but I'm going to go ahead and rotate it out because I don't want to slide myself, so I'll use my mouse wheel. But as you slowly go out, you can see how many more star systems there are. Let's go up towards the galaxy. Getting close. And you can start to see our galaxy form as we get to this spot. You can see where we are in the galaxy, and you can see the galaxy itself. Well, let's go look at other galaxies near us. Let's just zoom out. As you can see, all these dots, those dots aren't stars. Those dots you're seeing now are galaxies. These are other nearby galaxies. Okay, we're getting close to seeing many more galaxies. Now, every dot that's about to come into play is a galaxy. How amazing is that? Just look at the amount of galaxies there are in our universe. And the sheer fact that we can know this, that we can image this, is just a testament to how far science has come. Let's go out and look at our visible universe, because we can even do that. Thanks to the just raw power of these computer systems that we have. And here we go. This is our known universe. Something that's very lost upon flat earthers. But they can't get to picking and choosing around the things we know about our universe without explaining that first thing, the day-night cycle. Another thing that is lost on flat earthers like Arwijn, Dell, and Nathan Oakley, and Sleeping Warrior are some of the rarer, more mysterious things out in our universe. Like, let's choose one. We're going to look at black holes next. Black holes is my next point. But let's take a look at the galactic monster. Now, you got to give it a second to load in and render. And I really don't know a lot about this, but this is Sagittarius A Milky Way Central Black Hole. And I'm going to go ahead and turn on unpause time. I'm going to speed time up. Now, this is a galactic monster. I think it means that, so this is a black hole, and we're going to look at another black hole, a rarer black hole in a moment. Let's go ahead and adjust our magnitude and exposure so we can see what's going on really fast. We're going to have to really roll this down in order to see this. So this will be similar to my last point, but this is a sunrise over a volcano or something like that out in our solar system. And I just want to show you, it's very pretty. It's very cool looking. I want to show you what it looks like. This, of course, is lost upon flat earthers. They just don't believe that these types of things happen out in our world. When they do, it's provable. It's testable. It's real. But of course, they can't go on to, I would say, here, you know what? Let's pause this. Let's grab this. Let's right click and let's follow this object. I hit the wrong thing. We got to track the object. There it is. We'll track it from our position. Let's just speed it up. Okay, so it's rotating very fast now. Anyway, before these flat earthers could even complain about any of this, they would need to hit that first point I made. Tell us how sunrise, sunset works, how the day-night cycle works, the Terminator line works on your flat earth before you can move on to complaining about any of this stuff, whether it's real or fake. It's real. This is the Andromeda Galaxy. Of course, it's something that flat earthers say doesn't exist. It just is a light in the sky, according to Bob Nodell. But one cool thing about studying science, studying our universe, is, looking at how many galaxies are out there and just imagining, why and what's there. And how do you do that? How do you grasp anything about this when you think that all these lights in the sky are just pinpointed lights? That even though you can get a telescope and look up, I want to see what it looks like to fly back to the Earth from the Andromeda Galaxy, so let's go. And I'll make my final point as we zoom through another galaxy. Did you see that? Wish I could have slowed it down to do that. I'll figure out how and I'll show you eventually. My last point, I could make many more, and I probably will in another video, but for this video, my last point is, we hear so many crazy claims. These guys do their debate shows, and they do all their crazy discussions on Coriolis and other things, but in the end, if you can't get past the most basic, and I'm beating a dead horse on purpose, the most basic part of our existence in our day-night cycle, and show us how you can make something that comports with reality, a model that comports with reality, that literally we can say, okay, your model says at this time, this is where the Earth will be, the Moon will be, the Sun will be, Venus will be, and at where the light will shine from the Sun and the Earth, and rotation, or I guess flatation, whatever they want to call it. But, if you can't show me that, you don't get to complain about the Coriolis effect and have us take you seriously. You don't get to complain about other nuanced things out there. Those things, by the way, the Coriolis effect and those things, don't prove a flat Earth. Even if you were to find some error in the mathematics of the Coriolis effect or the representation of it, it doesn't prove that the Earth is flat. You have to start at the basics and work your way up. We can do that with our model. Anyone can test it, put it together, go out and make their observation, their prediction, whatever they need to do, and see that the model does predict those things and it does work with our model. You just can't do it with yours because you're lying. It's not real. You're fooling these people because they're willing to donate to you because it helps them find an excuse to believe in God.
Now let's go to the one you showed me for night and day. We all know that precisely half the Earth is experiencing day and the other half is experiencing night at any given time. So your model must reflect that, and this one does, but at the cost of being even remotely reasonable. You've got the sun illuminating half this surface with an arbitrary and rigidly straight line down the middle. How does this work? How does light leave this object and travel one distance to stop here, and travel some totally different distance to stop over here?